Hi there. Today I figure I would do another video, and this one's not going to be part of any series. It's going to be a one-off. So, one of the aspects I haven't really covered in any of my videos at all is how to do object-oriented programming, or how I do it, and how one might do a form of that programming to essentially create a miniature game engine. And that word and tutorial in the same sentence is very scary, because there's no way in hell I can make an entire game engine in any length of video. But what I can do is go through some of the concepts that go through my head, my thought process when I'm doing that kind of programming, and maybe it'll help someone who's watching. I will also say that this is not the only way to do this stuff. These opinions are opinions, and they're my opinions, and if you don't agree with them, well, then you can go to hell. I'm just kidding. If you don't agree with them, then, you know, there's nothing wrong with that. But this is how I like to do this. So I'm going to go ahead, and I hope I don't have a problem, but I'm going to use OpenGL and SDL for this example. So I've created a new project here in Xcode, and iOS and Apple try to kind of force their languages and their systems down your throat. But that's okay. We're just going to say this is Objective-C, but then in reality we're going to do this in C++. So I'm just going to call this Engerar. It's kind of a game engine, but not really. And essentially we've created a new OS X project, and what I'm going to do is I'm going to pull up previous work that I've done from a previous video, which initializes OpenGL 3.2 in a very simple fashion, and I'm going to replace all of the default stuff that comes with this project with that file, and essentially get all that other crap out of there. So I'm going to say new C++ file, call this main, put it in the project's main folder, and then we're going to dump the main that comes with it, and all the Objective-C related stuff that come with the default project, and now we just have main. Copy. Paste. Now there's a couple things that immediately won't work. For starters, it can't find OpenGL, and for seconders, it probably won't be able to find SDL. That's okay, because I know where to find these things, because I happen to have them downloaded into another place. So I'm going to go ahead and open up my game that I've been working on, which conveniently has some of these frameworks for me, and the one that I'm really interested in using right now is SDL2 and SDL image. So I'm going to go ahead and copy these into a subfolder of Engerar. Frameworks. Alright, now we have these frameworks. The kind of code that I like to write when I'm doing game engines is multi-platform. So even everything I'm doing right now is on a Mac. Essentially, it'll be the same code that can compile on a Windows system as well. So I'm going to drag these into the project, and I'm going to put them in the frameworks folder, which doesn't seem to exist, so just to keep myself organized here, I'll go ahead and throw these into frameworks, and I'm going to go ahead and put that down here because I'm OCD when it comes to this crap. Now you would think that'd be enough, but when you're using Xcode, it loves to have a problem, and this will not be enough to get it to work. So it still can't find GL3. We can go ahead and take care of that pretty easily. We can add a system framework, that means one that actually comes with the SDK, which OpenGL typically is. And that'll at least get the OpenGL error to go away. I said. Alright. SDL needs to find its header files, and even though I've dragged in the framework, for some reason Xcode doesn't think that's enough. So usually I go to the project settings, I go to framework search paths, but what I really want to do is go to user header search paths, and this seems excessive, but this is the way I've been doing it for a while, and it might be too not the right way to do it, but I go into the actual framework itself and go into the headers, and essentially that's how I find this crap. So, and then I drag that into the header search paths. Usually this gives a relative path here, but it's not right now, and I don't feel like finding out why. So now we should get as far as build succeeded. That's odd. Usually there's a linker error, but I guess I got everything set up right. While I'm at it, I'd like to add the header search paths for the SDL image framework as well. So I know I plan on using SDL image at least once throughout this video. So now, if I hit run, we get an error, and that's because it needs to find the frameworks at runtime now. This is the thing I was expecting to happen before. So last but not least, I add a build phase to the project. Copy files build phase that basically says these frameworks need to come with the program when it's distributed. And that goes into the destination called frameworks. There seems to be a problem with code signing, but that's fine because I don't plan on doing any code signing. So I'm going to go ahead and turn that off. Alright, so I went on for an hour after that, and the entire video got lost. QuickTime didn't save it right, and I wrote all this code, and I was outlining my process when I wrote it all, and I explained it all, and it was probably one of the better videos I've ever made, and it's gone. I've tried to recover it, and I can't. And I'm making this video, and I'm finishing it, and I'm explaining it to make a point. I'm really, really sick of the quality of software going down the tubes. It's really sad. This little icon up here, the little stop icon on the menu bar, should go gray if it's not recording anymore. As throughout the hour I checked to make sure it was still recording, and it said it was, and it wasn't. And that is not excusable. So because I care about this content and I put an hour of my time into it and it was gone, I'm going to walk you through the code in retrospect and at least explain what I did. But there's no way I'm going to be able to put the same amount of energy and enthusiasm as I put into the first go around. I'm almost sick, like with anger, over losing that file. But this isn't the first time this has happened either. But it might be the last time I use QuickTime to ever record a screen recording ever again, because I put pride into the code I write, and clearly the engineers who wrote QuickTime have no such pride, and they suck at their job. So I just wanted to say that before So when you're making a game engine, typically what you will want to do is you might start out with code like this, which is what I had in one of my other videos, which was OpenGL 3.2 code to just draw something with a shader. And as you start working on the game, you'll notice that the complexity will grow, and I'm a big proponent of only having the amount of complexity that is necessary for a game. Basically, you demand develop your code. You only develop the pieces of code you need, and you do it in a way that's as organized as possible so that when you work on the final game, or whatever it is you're working on, the complexity is mitigated. So there's the opposite extreme, where you put everything in one file to keep things as exploded or in one place as possible and to avoid object-oriented mindset of class creation, I guess. And you put everything in one file like this, and then there's the other side of the spectrum where you over-architect everything and you split things into way too many classes, and you get into a point where it's unnecessarily over-architected, which happens to a lot of big companies. I guarantee you the people that started when they wrote Unreal Engine did not plan on having that much complexity. They just got to it over time, and as you get to that level, you get to make decisions about it when it gets to that, but you don't want to aim to get to that for starters. So basically what I've done is at the result of the hour of programming, I took main from this, and I basically made it look like this, which is basically everything is embedded inside a C++ class called system, which is basically a class which is an abstraction for a run loop, which basically the constructor for system initializes the entire windowing system and all the boring OpenGL initialization stuff, and the destructor for it shuts the window down, so that when I hit run, the thing constructs, and when I hit escape, it quits out of the run loop and it destructs. So system basically looks like this. It has a constructor which takes the width and height of the desired screen. It has a method called run, which runs the run loop, a quick inline getter for width and win height, and some data in here to keep track of things like the OpenGL vertex array object, the window and the context, and system level stuff for that. When I write inline for quick inline getters, I do this with two thought processes. One is that it's simpler to write this than to split it between a header and a CPP when the code is so simple. And two, when you put inline, it's a hint to the compiler that it can inline this code, skip the overhead of the function call, and essentially speed up anything calling it, which is a really nice performance benefit. So what system basically does is on construction, it puts all the crap that was originally in mains inside the main function and puts it inside here. So the job of all the ugly stuff like constructing OpenGL window or SDL window and creating the OpenGL context, it's all basically embedded in here. OpenGL defaults are set up, it's all good. And then the destructor called shutdown, which closes the window and shuts down the system. And that's basically the bare bones structure of any game that you'll write. The run function is a simple run loop that calls my three methods that I like to have in all game programming, which is input, process, output. Process events from the SDL state might be like keyboard events and stuff like that. Update logic, updates in the game logic there might be. And then I have render, which is sandwiched between methods that you don't typically want to have to write inside every time you write render methods, which are GL context make current, and then swap window, which displays the screen result rendering. Process events processes the events. So system is kind of ugly, and it's the kind of code you don't want to look at, because looking at this kind of code that never changes, it's like write once, forget forever kind of SDL code, looking at it all the time and scrolling through it when really you just want to be working on the game, which changes a lot, can be very grating on your psyche. So what I typically do in this case is I will subclass the system class, and I just called this one demo system. And what this does is it uses all the components of the system that I had before, but it adds new stuff that I will be working on a lot without having to look at that other crap. So basically what I have is I have the same three methods, but I've declared them virtual now, and they should be virtual in the original, which takes advantage of polymorphic inheritance, so that when I call process events, update logic, and render, I essentially overrode the ones that were present in the original system class to include my specific stuff to this specific demo. I'm not going to show any more code in demo system because it's kind of the thing that pulls everything together. So a couple things that what should go into a class object and what shouldn't. That depends on essentially how complex your system is. Again, demand-driven engine development. So there's a couple things that I know that I should have for a very simple OpenGL system, which might be an engine for a very specific game. I tend to write engines catered to specific game projects, and I tend to write a new engine for almost every game I do, with the exception of the direction I've been going lately, where I tend to have a bit of a bigger game engine. But the game itself typically still has an engine feel to it that uses other components. So one of those classes I just pulled out into something basically called transforms. And what transforms does is it manages a lot of the crap that used to be built into OpenGL for me. In this case, matrix manipulation or matrix transforms. So I basically have my old struct mat4, which can remain as a struct because it's low level, an identity constant for the identity matrix, and then my transforms class stores basically two properties, model view matrix and projection matrix, initializes those to the identity matrix, and then has methods to set the perspective projection matrix for me, set that up, and to do just a quick translate transformation and apply that to the model view matrix. And then, of course, when this is all done, I can retrieve the final model view projection matrix, which is the composition of these two things, which is useful for, like, if I was giving that to a shader. So I pulled out my ugly C functions, which handle some of this math for me, and I just put those as static void. They're global C functions, but because static is there, they're not as global. They're essentially still scope limited to this transform CPP file. And then my implementation of the methods for transforms is super simple. It's just model view matrix initialization, perspective matrix stuff, translation matrix stuff, and then of course the method that composes these two things via 4x4 matrix multiplication and returns the result. I really hope QuickTime is still recording. After that, I have a more common thing. I think if there's anything that deserves to be put into a class among all the other stuff that was originally exploded in the original program, it's definitely shaders, because OpenGL shaders are split into tons of different little API calls, and they're kind of really annoying to deal with, so putting them all into one class is a great way of dealing with shaders in C++ and OpenGL. So what I basically have here is an extremely simplified shader class, which contains the GLUint, which is the shader program handle, a location index of one of the uniform variables that I'm going to set. In this case, the only one supported by this class is the model view projection matrix uniform. This class is initialized using two arguments to the constructor. One is the vertex shader and the other one is the fragment shader, both supplied in source code form. And then I have a method called use, which binds the shader to the OpenGL state. So basically you use a shader, and then once you're using it, all subsequent draw calls or calls to draw 3D geometry will use that shader. Then I have a setup method, which basically makes sure that the transforms information, which is conveniently stored and encapsulated into my transforms object type, transforms class, is used by setup to populate the model view projection matrix and whatever other state I might store in there to the shader. So here's all that code I originally had exploded in the main, but now more conveniently encapsulated. This is all hidden now by the shader class, which is nice. Basically, it creates the shaders, builds them via their source code, compiles them, uses it to obtain the initial model view projection matrix location index. And then my destructor now, so whenever the shader is destructed, will conveniently delete the program, release the resources that it uses, which is nice. And then my setup routine, all it basically does is retrieves the model view projection matrix and supplies that to the uniform matrix. Supplies that to the model view projection matrix via uniform. I'm sorry if I'm not explaining this as well. I'm just, I'm still not that thrilled about losing the first video. So we've covered transforms, we've covered system. So the other last remaining class that I have in here in my my component system is basically the model class, and this is a very, very simplified example of maybe how you would put a 3D model into its own class, which basically consists of the VBO and EBO handles to the OpenGL buffer objects, and a vertex count, which is basically just how many vertices that this particular model is going to draw. Now in a real-world engine, this thing would typically have code to parse models from specific file formats, so it might have like an OBJ file parser in here, but for the sake of example, this thing basically just fell back on that generate sphere code that generates a sphere on the fly. So basically every time you call model, it just generates another sphere. And this is the OpenGL code that basically generates and populates the OpenGL buffers containing the vertices and indices for rendering a sphere object. And of course it destructs those properly on deinitialization. The render call basically handles all the ugly stuff, the multiple API calls you have to do in OpenGL to just draw one model, one mesh, and that's all encapsulated into the render method to essentially enable and bind the vertex arrays properly and make a call to draw elements, which basically draws the triangles needed for the model to work. And that's all conveniently encapsulated really in this model class. So now that I got all that, I can bring all this stuff together in my demo system class, which basically has transforms, C++11 shared pointers to a shader object and a model object, one of each for this example. And these shared pointers are nice because as soon as the last pointer to a specific object is gone out of scope, it will automatically delete and free those objects for me. So the demo system constructor is very simple. It basically calls the superclass constructor via this ugly looking syntax right here. And once the superclass system has been initialized in the OpenGL window and context and been set up right, I create a sphere, very simple, using just this built-in make shared C++11 shared pointer constructor stuff to create one of those. It's very similar to just doing this, but it automatically tracks the memory. And then I inline some source code for an extremely simple shader, which does some very simplified shading. And I pass that shader source equal to a construction call to create my shader object. I set up my transforms object to basically have a 45-degree field of view angle and utilize the width to height aspect ratio to set that projection matrix up properly. And after this, it's all very simple. You can see it's very nice to work with code with this level of abstraction. It's just all built out really nice. So process events, I make sure very carefully to call super here because I'm overriding the original method, and of course I call the superclass update logic method as well. For render, I'm completely overriding render, so I don't need to call super. And I basically clear the color or clear the screen. I set the transforms up. I do a very simple translation matrix transform, which pushes the object 10 units away from the camera so you can actually see it. Remember, this is all implemented using my other code that I already had here before, which is much nicer to look at something like this than what I had here, all in one place. And then I use the shader program to bind it. I set it up to make sure it gets the model view projection matrix from the transform class, and I render it, and the end result is something like this. So that's the basic example of object-oriented mindset when doing engine development. Again, I apologize, it's not as good as the first video, which is lost to time, but I felt like I had to at least finish what I started. So thanks for watching, guys. Bye.